question 40 from homework 1 really can be a challenging question. Questions like this, where they throw many different numbers at you, and it really helps to just confuse the process when we have to look at all these numbers and think about, it could be overwhelming. I don't know where to start. So a good place to start is mapping out the calculation, mapping out each step to the calculation. So they give us that we have 19.2 gallons of gasoline, and they want to know how many pounds does that weigh. They give us some conversions of gallons to liters, the density of gasoline, and then a conversion from grams to pound. So looking at the information we have and the information that we're given, we could say that a step would be, well, I have 19.2 gallons. I need to turn that into liters, because once I know that volume in liters, then I can convert that to milliliters and then use the density to convert that to mass. Once I get that in grams, one final conversion and I can turn that into pounds. So we are looking at a 1, 2, 3, 4 step calculation, where step 1 would be gallons to liters using the conversion provided. Step 2 would be a metric conversion, liters to milliliters. Step 3 would be, again, a conversion with the information provided, density. And then step 4 would be the same, a conversion with the information provided. So step 1, 19.2 gallons. And I know that in every 1 gallon, I have 3.7854 liters. Gallons cancel out, and I have approximately 72.67968 liters. Step 2, I can convert that into milliliters. So 72.67968 liters. I know that in every 1 liter, I have 1,000 milliliters, so multiply by 1,000. Again, keeping track of units, liters cancel out. So multiply that by 1,000, I have 72,679.68 milliliters. Now that I have the volume in milliliters, now I can use the density. 72,679.68 milliliters. Density allows me to convert from volume into mass. I know for every 1 milliliter, I will have 0.749 grams of gasoline. So again, keeping track of units, milliliters cancel out. I multiply by 0.749 and I'm left with approximately 54,437 grams of gasoline. Now I'm ready for step 4. Step 4, converting from grams to pounds. 54,437 grams. And I know that in 1 pound, I have 454 grams. Again, keeping track of units, grams would cancel out, and I'd be left with 120 pounds. Taking a look at significant figures, this is a defined number, this is a defined number, and this is a defined number. The only number that we measure would be the volume of gasoline. There's 3 significant figures there. So to report the final answer to 3 significant figures, I would say I have 1.20 e to the 2 pounds of gasoline. And again, at first, this might seem like an overwhelming calculation, but we just want to take into account a pathway like this. Where am I starting, and what am I looking for? How could I use this information in between to get between the start and the finish of this calculation? So I would recommend mapping out these problems and taking a look at the information you're given. How could you use that information to map out the problem and figure out what would be the steps involved in a calculation like this.